So we are now going to look at chapter 6, and the big subject here is orthographic projection. This is the standard on how we lay out parts, lay out drawings to release to production. Okay. Now, I'm going to tell you right away, when we are using parametric software, solid modeling packages, what you're going to get to, in the future in the program, Creo specifically is what we use here at WCTC. You might even know, those can already lay the drawings out for us. Why are we worrying about that? Well, as you know, a machine software is only as good as the person who's running it, right? So guess what? SolidWorks can lay it out for you if you wanted to, but it's not perfect, okay? And especially when we start looking at the views that it picks and also how it puts the line work in place, we got to fix that all up. So we have to first know what the standards are and how to lay this out, if you would, in that foundational setting and doing it manually, so that when we get to the part of doing it more automated, we can make the fixes and also check what a software does for us. Okay, that's really the main thing. So, so in chapter 6 here, we're going to be learning about orthographic projection, and then continuing throughout the program, especially as you make drawings and models and documentation to send to be produced, we're going to continue to apply this. So I'm not going to read through all of this stuff on this list. We're going to be doing a lot. Okay. So understanding first and foremost projections. Okay. Now we already got an introduction to this in the sketching that we just did in chapter 3. So we kind of had a line of sight and we're like, okay, now draw straight on what that looks like. We're going to continue to do that, but we're going to change our line of sight to get a full picture of the actual model. Okay, so in this case, you'll notice we have this, 3D pictorial of this part and a front view. If we would be looking straight on, like I'm kind of pointing in the perspective we would be going at, but we would be looking straight on this way. This is going to be the view. So if we take that part and we just look straight on, this is what we would see. Now, as we look at this view, the important part about it is that there's a number of elements here that are in their true size and shape, meaning when I see this arc going over the top here, this radius, it is going to be drawn to the actual radius. All right. And when I dimension it, I can point to it, I can select it, and it's going to give me a dimension that reflects the size it was drawn to exactly. Same thing for this hole, this diameter. I'm seeing it straight on. So I'm looking straight down that hole. So I only see the actual edge of that circular feature. And when I draw it and I dimension it, it is going to be right on. All right. Same thing for the height and the width of that cutout. All right. This is the front view. Now, as I look at that front view, am I missing anything about that part?
You wouldn't know about the fillets.
I wouldn't know about the fillets right here. We see fillets right here. When I look straight down, I see fillets there. What else wouldn't I know? I wouldn't know the depth. I wouldn't know how far back this foot goes or how thick the top part is, right? So what do you think I need to do to make this more complete? This is a good start, right? But it's definitely not something that's complete. What would I need to do?
2 other views.
Yes. For some of you who maybe have experience with this, 2 other views, but how do I do that? I heard side view over here. What does that mean to me? I'm going to change my line of sight. I'm going to now look down this side, right? And look straight on and maybe draw that side. So now I can see how thick that is coming down and then over how wide that is, right? Good. So what we're going to be doing, orthographic projection is going to be a standard way of laying these things out, but we also are going to be responsible for picking more views so that we get a complete view of this part. Okay. Do you see how that would be really important? This be, again, a good start. We could send this out. We could give even all the dimensions on it, but somebody might be like, how wide is that at the bottom? Or how tall is, or how, you get the height here, but, what are our thicknesses? What is the material? How wide should I, pick, stuff like that. So there's still more information here. So views of an object, there are standard views that we use when we're looking at parts. And we already have identified that front view first. Okay. So it's kind of like the front of the part. And then we're gonna have a right side, a left side, a top, a rear or a back, sometimes it's referred to, and a bottom, okay? Now, it's not super obvious in this case, but each one of these views is 90 degrees to one another, okay? So it's literally like looking straight on and then switching your perspective and even the part and moving it 90 degrees, rotating it. And now what does that look like? Rotating it again. What does that look like? Then rotating it this way. And we'll see a view in just a little bit. But this orientation of that front view is this perspective right there, looking with that, what we call line of sight, line of sight. Now, using kind of our house, I think this is a very relatable example. So in here, we see that we use this a lot, even though we're not anticipating being architects, okay? But you can kind of see here, we can lay this out with multi-views as well, where we stand right in front, bless you. We stand right in front of our house. Here is the perspective, and we're going to draw right exactly what we see. That's going to be the front view, if you would. That's the layout. Then we're going to go to the right side, and they call these in architecture elevations. Okay, we call them projections or views. Then we can go and we can stand on the left side. We can go look down straight on it, okay? Or we can look at a bottom view, probably from the basement up, okay? Now you'll notice something about these views. As we look at the drawing, all right, I'm gonna zoom in here, make this a little bit bigger. As we look at this drawing, notice something, that in our front view, the ground level, or if you would, the bottom of the house that we see in this view, there's probably basement down below. But this is all in line across each one of the views that we create. Do you see that? That's common. The height additionally is at the very top of that chimney. If I take a straight line, I go over, those are all in line with one another. That's called orthographic projection. We project the same height for each one of our features across the views. Okay, we project across the views. That's what we say. They're in line across the views. You'll notice that top to bottom is, or I'm sorry, front to top. That left side is in line with the right side. Actually, it's not in this view. I don't know why. It should be shifted over a little bit so that this right here would be in line. Oh my goodness, that's a terrible example. That is, Pearson did not do a good job here. Should be shifted over a little bit so that your front view, your front door is going to be in line here. That's called orthographic projection. Okay. Dang it. I glanced at it, and now that I'm looking specifically and talking it through, not as good as I thought. Okay. So I like this progression here. Notice how the person is holding the part. And as they're looking at it, they want to look straight on. So you're holding the part in front of you straight on. That is going to be your front view in this case. Now, we pick our front view strategically. Most often we pick it because it gives us the best sense of the overall shape of that part. Okay. All right. We'll see that in some other views. So a lot of times that front view, and then off of that front view is where everything else is projected. So your side views are projected off of that, top view, bottom view. Okay. So revolving the part to produce the view. So we start with that front view, and we literally, to get, let's say, a right side view, we turn it 90 degrees and we look at that right side and we see what we do. So you'll notice here we have front, we rotate 90 degrees until we get straight on to that right side view. And there it is. We can do the same thing, start with the front view. And now what we're going to do is we're going to rotate it down so that we can look at the very top view. So you see it rotated down, down, down. Okay, 90 degrees from where it was at originally. Okay, and then now this would be the view, and this would be the view. All right. Now, principal dimensions. There's 3 principal dimensions on any part, all parts. There's the width, or sometimes referred to as the length, because many times when we see it in a view, it's going to be the longest horizontal, like in a front view, the longest horizontal dimension. So we a lot of times call that the length or width. Then we have the depth. How far, if you would, into the screen is it going to be, right? And then how high is it? And that kind of gives us the overall. So a lot of times when we, for instance, buy something on Amazon, we want to get a perspective of how big or small it is, right? You ever bought something on Amazon and it came like completely different size than what you expected?
dimensions?
You do, yes, you check the dimension, you check the specs. I remember buying I forget if it was a t-shirt or something. I bought it, it came and it was like this big. I'm like, really? But when I looked at the details, they did give me the dimensions and I just didn't see it, right? So it was a great deal though, right? but check the dimensions because it's going to give you what those overall width, depth, and height values are. So you can then kind of plan it out and kind of get a feel for, you know, what is the size that I'm expecting when it actually arrives. Okay. So those very same principal dimensions are something that we're always looking for. We want to make sure that this is going to set for us how much material, the box, if you would, that has to fit into. How much material do I need for this? Okay. Now, projection methods. So as we said earlier, it really is. Now, I think sometimes it might start to get a little confusing. I think they try to clarify things, but it's as easy as I'm looking straight on. I think that's the easiest way to think about it. But what you are doing, it says a plane of projection, your frontal plane of projection. All that means is you're looking straight on, and now I'm drawing on a piece of paper that would technically be in front of me, that profile. That's all that is. Okay, so this is now the view. We already did that when we were looking at our pieces of paper. We were looking straight on, okay? And what I saw? This is like that front face right here, that plane of projection, that frontal plane of projection says, I'm going to assign the front view to be on that plane of projection, and I'm going to draw it. That's it, okay? Now, horizontal and profile projection planes. Again, horizontal horizontal projection plane, I like to say, is the top view. The plane is horizontal with relationship to the part, but I'm literally just looking at the top of it. And the piece of paper, if you would, that I would put there would now be a reflection of the view that I would see as I look straight down on it. And that would be called the top view. They call it a horizontal projection plane. The profile projection plane is going to be, in this case, it's on the right side of the part in relationship to the front view. And now it's looking straight on. And again, drawing on my piece of paper, what I see in that projection, okay, or in that view or that line of sight. Okay. So it's just a way that you can visualize where the views are coming from. Now, I really love this analogy, and this is something that's very classic to orthographic projection. Is let's say I would take a glass cube or a glass box, and that cube or box, all of the planes, all of the sides of it are 90 degrees to each other, right? So you'll notice that I have a flat top to my glass box. I have a flat front to my top box, my glass box, right side, left side, bottom, and back. And if I would, for instance, have the ability to suspend my part inside of that glass box, when I take that glass box and I look straight on to one side of it, all I'm doing is drawing on that face. What does that look like? Okay. And that's my corresponding view. So in this case, this is my front view. Then if I look straight down on it on my glass box, there's my top view, right side and or left side, back and bottom. Okay. So you can think about it. I think that always kind of helps a little bit for this visualization and what I'm going to see. Now, laying out these views then, if we take that glass box and we unfold the sides. So you know how when you get your Amazon box and you have to break it down to put it into the recyclables? That's kind of what we're doing. We're unfolding that box, and alongside, all we're doing is we're bringing those views along with it. So you kind of see, and the key here is that our front view is what everything is getting unfolded from, because our front view, once we pick that, remember what I said earlier, everything has to be in line across and up and down. Okay. So we're unfolding our box. And now once we have it all unfolded, this is what we have. Okay. Our front view is in the middle, strategically picked. To the right, in line, is going to be our right side view. Our left, and then additionally our back as we unfold that back side to be on really one side or the other. It could be on the right side folded off of, or it could be on the left. Then we've got our top in line this time. Notice that those lines are in projection. Our architects didn't do a great job. And then down here is the bottom of the part. Now, as we look, I want you to see a couple things. First of all, there are 6 principal views, 6 principal views. We don't need them all. It would get very cluttered on a drawing if we drew all 6 principal views all the time. Bless you. What you are going to do as the designer, you're always going to pick the best views that are going to give you all of your information so that we have each feature in at least 2 views. All right, that's one of our rules. And we'll apply that. So the most popular 3 views to start off with are the front, top, and the right side. All right, that's where we start. We may make decisions, and we'll talk about those decisions later on. If more clarity is brought by doing the front left side and the top, then you do, okay? Then you do. But front, you pick your front so it gives you the major shape of the part. It also is going to have the fewest number of hidden lines in it. That's the other thing that you strategically pick, okay? Once you have that, then that's how you decide on the next ones. If I go to the top view, does that give me the most clarity? When I compare the top and the bottom, do you see how they're very similar? But what's the difference? What do you notice about the top compared to the bottom? They're both in line. They both still give us the width dimension and the depth dimension. But what do you notice the difference about top to bottom? Yeah. The top has fewer hidden lines. When we have edges that we're looking at, it's easier to look at. It's easier to interpret. Okay. So it has fewer hidden lines. So if you're trying to decide between the two, that's going to be your next, deciding factor. So yes, the top has fewer hidden lines. As we look and we try to decide, the right and the left look pretty similar, right? The right and the left look pretty similar. Which one would be a better view to include if I wanted to give the clearest picture? Go ahead. Why did you pick the right, Tyler? It does have one less hidden line, and that makes it less hidden lines. So the right it is. Okay. But again, 6 is overkill, but you may have reasons to have more than 3. You may have reasons to have maybe less than 3, 2 at least. All right. 1 is never really enough. Okay. None is never really enough. You want to at least have 1 other view, 2 for sure. And then you want to be sure that you can, see each one of your features so you can dimension it. All right. So let's look some more at orthographic projection. So once we have our views picked, and you'll notice in this case, and we're going to look left side first. All right. We have picked the front, top, and the right side view. All right. Couple things. Notice that the bottom of the part is in line across the views. The top of the part is in line across the views. Top to bottom, the same thing with the left and the right edges. Okay. Now, as we look at the front view, again, strategically picked to give us the best and the major shape of the part. So this looks good. Now, as we look at features, for instance, such as the hole that's in here, when we project straight up, and I'm using the center line first, projecting straight up, notice that it's in line with the center line. And then in this view, we don't see it as a circular feature. Instead, we would see, it would be looking down through the material here. So I really wouldn't see the hole at all, but I'm going to recognize and say there is a hole there. So we will put it in and reference it in terms of hidden lines. A hole in the view where it's not seen as a circle will be represented by the width of the diameter. So you'll notice that this, what we call the quadrant on one side, and the other quadrant is then going to be the line view to show us, that part on the upright where it's going through. Okay. Over on the right-hand side, we see that very same thing. We're in line with the center line here. And then you'll notice in this case, we're going to see the top and the bottom quadrants as the hidden lines going through, because when we look through that, if we look from this side to that, we hit material, we're not going to see that hole. Okay. Now you'll notice that they have folding lines in this view right here. Those folding lines, what do you think those represent? We go back here. What do you think those folding lines represent? These are the three views we're looking at. Do you see that? The edge of what would be, I'm going to go back here, our glass box, right? It's this edge unfolded. They call them folding lines, right? So in the olden days, we created everything manually, and you'll get a little experience with this. It's not like you're going to perfect this craft, but we had to put folding lines in. And then we measured from the folding lines how far back our features were. And that would set for us its placement in the view. Okay. So you'll notice we have a dimension or a D1 here. That's from the folding line back to where the front of the top view is going to be. So if I go back over here, that's going to be this dimension from the folding line back to where that view starts. Okay. And so on. And then we would do that same thing, folding line between the top and the right side. And that's this folding line here. And then it tells us, oh, how far back is that point going to be into our view? Okay. Now, over on the right-hand side, you'll notice that we have the very same drawing without the folding lines. The folding lines would go in for the construction, and they would be construction lines, as we saw in the sketching, chapter 3, and then they would be erased after they would be created. Okay, so over here is really where you see them omitted. But now what you are going to notice is that some of the dimensions are going to be in the views, in at least two views. So let me go back up here for a second. Those three principal dimensions that we talked about, the width, the height, and the depth. So the width is going to be, like I said, sometimes referred to as the length. It's right here. And you'll notice that it's common between the front and the top view, right? The other thing that we get here is going to be height. We have a height dimension, but this time the height dimension is going to be common between the front and the right side. Okay. And then the depth dimension doesn't happen in the front view. That's just going to be that frontal plane. We get depth from, and you'll kind of see how this kind of goes around the corner here. We get depth in the top view, and we get depth in the right side view. And you see how those are in line with one another across the views, like when we kind of go across. And that's what we see here. So D2 and D2 are the same. D1 and D1 are the same. Those are like those depth dimensions. We don't see D1 or D2 in the front view because we're just looking at the front plane. Those are like into the screen, if you would, or into the page. Okay. So good. So transferring those depth dimensions, we can do that by measuring, or there is a cool drawing trick that we can do. And we can do what we call a miter line, all right? And it really does that kind of bringing across. So you'll notice here that we have the miter line, the front face and the front face are going to be in line across a 45-degree angle. And then the back face from the top view to the back side on the right side view is then going to be in line there as well. So if we measure it and draw it out in a top view, for instance, we can construct it over the miter line to be in line for the right side view. We'll get a little experience with that when we start doing some of the practice that I have for you, okay? Now, again, necessary views. It is good to start with thinking what, we know we're going to have multiple views. We first pick our best front view, and then we pick additional views based on, how clear they are. Normally, we start with a front, top, and either a right or a left side, depending on which one makes the most sense. So a front, top, and a side view. We'll see it as a right side most often. But if we can clearly get the information across in two views, we do it. Or if we need a fourth view, we do it. Okay, and that's going to come down to dimensioning. But for right now, we'll focus on just the views themselves. Okay. Choice of views and how we're going to lay them out. I don't know. I think any one of these can go either way. And it says here that the top, here's a good example. They say poor. I think we can look at good and okay. All right. both of these are still in orthographic projection. Both of them get a depth dimension for us, bless you. And really what it comes down to, what I like to look at is, how does it fit on my border? Okay, if I can get all of my dimensions around here clearly, have it on my border with a title block, I think I'm fine. Okay, and that's going to be another thing that we introduce kind of in how it's laid out. So I think, yeah, this is good. I wouldn't call the one on the right poor in either case. Okay, it's just depending on how it's going to fit on our drawing, which one seems to work better. Actually, a lot of times your horizontals are going to work better than your verticals because of the way the drawing border is going to be oriented. Okay, so again, I wouldn't use the strong word of poor like the book does. I would just say maybe good and maybe better on this side. All right. The next one here, one view. This is something I disagree with the book about. And not because, you know, I'm better at this than they are. I just disagree with the book. They have a one view drawing here, and it says that the stock is made out of 65 millimeter square cold roll steel. All right. And that's all we know about it. Always at least two views. It brings clarity, because then as we look at this, do you see how somebody can glance at this? This is a center line going through here. Center lines most often are going to be, they show lines of symmetry, but people go right to, these are circular features. So when I look at this end part, this collar, okay, it's got the square in front of it, but do you see how somebody could jump to this and be like, oh, that's circular with a glance? Okay. But if there would be a side view showing the square on that side, now it's clear. So this is not a good idea, especially when you're sneaking in a square feature like this. Okay. So, so always go on the side of even giving more information than needed to clarify it, because you don't want to assume, for obvious reasons, somebody's going to catch that. Okay. And they're going to come back and be like, oh, I didn't notice that. And all it would have taken was a simple extra view on your drawing to really clarify that. Okay. So not crazy about this. They're okay with it. I'm not. Then kind of going back to the choice of your front view. You always want that first view, that front view. That's the center of the world on your drawing, right? That's where everything gets projected to the top, to the right, or the left, or down. Okay. That's an important view to pick. And that's what you pick first. So when you look at a feature, when you look at a part, what is kind of its natural state and what's going to give us the best sense of its overall size and shape? Okay. So when we look at a car, for instance, this is the best view to kind of give us like, really, what does it look like? And that front view is what you want to get the most information from. You wouldn't draw it going down a hill. You'd show it horizontally on a flat surface, right? You wouldn't show the front of it because that doesn't give you the full picture or a bigger picture of what it looks like. And additionally, you wouldn't show it going up and down like this. So you would start with kind of its natural state, and the front view is going to give you the best size and shape of that part. And then you're going to project from there. Then you would project a front view over to the right side, or I'm sorry, a right side view over here, looking at the front of the car in this orientation. Then you would look at the top going down. And then probably in this case, this would warrant a fourth view because the back looks very different than the front on a car, right? So you would probably have a left side view over here for sure. Okay. And then the bottom looks very different than the top. So you might have a bottom view as well. So, so you can see how the more complex parts get and how they do look very different on different sides. You would have to continue to add views as needed. And that doesn't mean you can't. Many parts you want to start with what 3 are the best, and then see if you can go down to 2, but then also, do I need extra? Do I need to go beyond 3? Okay. Third angle projection. Okay. You know how the metric system like makes everything easier, and it's a base 10, and it's like, how come we can't do that? How come we haven't been able to, you know, go from inches and feet to millimeters, centimeters, meters, right? It's like so easy. And you kind of feel like, okay, they got that one right. We got this one right. Okay. Third angle projection is used in the United States and Canada. That's pretty much it. Okay. Everybody else uses first angle projection. Okay. And I'm going to kind of, they went ahead and they explained it, which I think is fine. But essentially what it is around our glass box here, on the surface that's closest to us is what we project our view to. So we see what's going on right there. That's third angle projection. First angle projection, which is the rest of the world, okay, which is going to be the, you know, like Europe and everybody else, China, they all do third or first angle projection. First angle projection takes this picture and it pushes it to the back surface. And that's your front view. So actually it's projected back here. And then your back is projected to the front. You like go through the part and you push it to that surface there. Don't even think about it. So there's two of them. There's first and third. We're always going to be in third. That's the standard that we're in. And so we're always gonna project forward to the surface that we're on our glass box. Okay. So, so third angle projection has a symbol that will be in title blocks. Title blocks are going to be down in the left-hand corner. That gives you kind of that basic information about a part. And part of that is letting you know what angle of projection this is drawn in. All right. And so we will always be in third angle projection. Position of your side view. Now, here again, picking your views becomes important. Okay. So first and foremost, where's our front view? Okay. And then in relationship to that, you want to put your top directly above it, if that's the one that you're going to pick, and then your right or left side on the either side. Now, again, they're using the verbiage of poor and good. Now, as we look at this sheet of paper down in the right-hand corner, this is what we call the title block. I know we haven't formally talked about title blocks yet because we haven't like created drawings, okay? But title block is going to give you the name, the part number, the material, the scale. I think we did briefly talk about it a little bit, but it's on the bottom of each drawing that's like officially going to be made, you know, for that company. And their you know, usually their information, their logo is going to be down there. So that's always kind of like a place. So you'll notice that they have poor because really this side view is right on top of the title block. Now with CAD, we can kind of push things up and we can maneuver things around. I don't think that's a bad view at all. I actually like that view and I would try to make it work. And the worst case scenario is you put it on a bigger border and then you make yourself a little bit more room. That's fine. Over on the right-hand side here, to me, that side view, yes, it's in projection with the top view, which is legal, but to me, it's not its natural state. And I always like to look at it where I've got my right side, and it's going to be in line with the front view. And then I've got my top view. So I would tend to actually go in this direction because that's mostly how people think as well. When it's a right side, you're pulling off of your, you know, you're just turning your front view 90 degrees and now it's right there rather than looking at the top and then looking down at it. It's just not the natural way to do it. So again, I would change the verbiage here and based on the size and the placement of that title block, I think this is okay or good. And this is maybe better for spacing, but I still think visualizing, this is better. So, so again, not hard and fast rules here. You just want to make sure that you've got good placement. And then again, we can change things about the placement of that title block in order to make it work for us. Here's that first angle projection. Again, here's our glass box. And instead of projecting forward to the surface that we're looking through, they're projecting, as you can see here, to the back face and it's really like through the part. And then their symbol is a little bit different. So we will not, according to our standard here in the United States, we teach to the ANSI standard, which is third angle projection. We're only going to do third. Know that it's out there. And if you're working with a company that is global or you're working with drawings that you know came from another country other than Canada and the United States, you want to just look to see, because otherwise you could be completely backwards. Okay. And then go from there. So know it's out there, but we're going to practice and we're going to apply third angle projection. Hidden lines. So as we know, hidden lines are always going to depict based on features from that view that we don't visually see, but we're going to recognize and make sure that we understand that they are there. And we recognize them by using dashed lines for them. So you'll notice on this part here, if I look straight on through, there is this countersunk hole. That countersunk hole, when I look here, is not going to be seen in what would be the front view. But I don't want to forget that it's there. So we always put all of the hidden features in all of our views. The only time we omit them is if they start to have hidden lines over the top of each other and it gets too busy, okay? So otherwise we leave them in. And we always draw them in every one of the views that we're going to see. Center lines are going to be used to depict the center line or the center axis of a circular feature first and foremost, but it also can depict motion and or a circular or a pattern of holes. We saw center lines between holes before, so they can be used for that as well. But most often it's going to be a circular feature like a hole in this block. And then we see it in the other views as a line, okay? And then we're going to show the sides of what would be the width of the part or the diameter on either side. Now, precedence of lines. Precedence of lines means some things are a higher order, if you would, than others. And for instance, a visible line will always take precedence over a hidden or a center line. So you'll notice here that even though we have a center line in line with what would be an edge, do you see this edge that's at the top here that has to be depicted? The edge is going to be over the top. We can extend that center line out to show, oh, it's there, but we would never show a center line instead of a visible line, okay, like a visible edge. You notice that you will get that very same thing over on this side, because over here, a hidden line is on that back edge here. That takes precedence over a center line. So the hidden line is going to be shown first. So, and then also the hidden line, the top of the circle is in line with that edge. So the visible line is going to take precedence over a hidden line. So it's always going to be visible, hidden, and then the center lines. Center lines continued. So again, when we have circular features, we see them going, in that side view in line. Here's where we see it on a bolt circle to show the relationship that they're all the same radius away. Here we see it for motion line so that we can see something in two different directions. And many times we see this on, for instance, assembly drawings, where we want to make sure that we are taking into consideration like a full, like in this case, path of motion, so that we don't have anything else interfering with it. And then development of views on 3D parts. So as I said earlier, as you get into the parametric modeling software, which will be coming after this class, Creo, what you'll be doing is you'll be actually creating the model first, and then you'll be creating a drawing from the model. And yes, Creo will be able to lay things out automatic-ish, but you still have to make sure and make any corrections that need to be done for it, and especially in the dimensioning realm. So we'll go deeper into that, but this would be a representation of a CAD drawing. The nice thing about a parametric CAD drawing, because you have that model, you can always add that so that it, again, adds clarity to the views that you're looking at here. These views are not easy to look at. You know that? I mean, when you look straight up and on the left, left or top or right, and you just have that and you don't get this, it's like, yeah, think here a little bit. You got to kind of go between the three views. And that is something that it doesn't like click like this, like automatically, especially when you have complex parts. Okay. So don't think that after lesson, number 2, module number 2, chapter 6, I got it. All right. That's where we're going to continue to practice and practice and practice. And this visualization thing comes over time. It's going to happen, like you're going to get it. For some people, it's going to be sooner than later, but there's no race to when it becomes, second nature. Placement of our views. Okay. So this is really important, because whenever I cannot emphasize enough, as a designer, you make the drawing once. So put your best foot forward. You might not think of it in terms of this is a work of art, but it kind of is. All right. Because once it's created, it's now going to be used as the standard for how that part is going to be made. Okay. So what you want to do is you want to make it as readable and clear as possible. So first and foremost, you want your views to be large enough on a drawing with a drawing border, but not too large that you can't space it out and put the dimensions on. Because additionally, we would need dimensions here. We have to call out the sizes of all the elements and features that are on this part, okay? So you have to have a little bit of room. So right now here, these are a little close, right? Because if we would try to add dimensions between here, we wouldn't have much room. Beauty of CAD is I can move them, you know, so and I still seem to have a lot of room. Then if we move them apart, we don't want to go too far apart because we still want to maintain the relationships and see where things are in line. So yes, you end up having a lot of room in between here above dimensions, but kind of too much. Here's a nice happy medium. All right. So, and that's going to, again, come with, you know, some experience and being able to lay things out. Okay. Isometric views, like I said earlier, we're not focusing on being able to sketch those manually at this time because our solid model programs are going to be able to drop it in for us. But if you've created a part in a parametric solid modeling program, then why not utilize that model to add clarity to the other views? And we do that not only in individual pieces, but we do that in assemblies as well. Okay, so so you'll see us drop those in, and especially when we've got room for it. And here too, this is what cracks me up. Remember earlier where they had the layout where you had your front view, your right side view, and your top like this, and it was by the title block, and they were like, poor decision. They just did it, right? And now when they say that there's wasted space up there, no, you can put your model up there. That's not wasted space. You can add clarity because of, you know, the technology that we have. So again, it's not hard and fast where these are going to go. Just make sure that as we add our dimensions, as we see here on our drawing, there's enough room and it's readable. That's really what you're going for. You don't want them too close. You don't want them too far. You don't want the views too big that you can't get the dimensions on. And I always want to tell students, you do this once. So if you pull the border in and we haven't done that yet, but when you pull the border in, let's say it's a little too small. Don't be like, it's good enough. I'm just going to squeeze my dimensions in. I'm not going to accept that. All right. Because all it takes is deleting it and pulling it again at a different scale. And now you're good. And you do that once. You've spent an extra 30 seconds when somebody's going to be looking at that drawing 3,000 times. Okay. All right. How many of you, and this is usually, and it doesn't mean that if you don't have this trait, it doesn't mean that you're not going to be good in this field, but a very typical trait of people who gravitate towards this field. Number one, you kind of like drawing and you like creating. Okay. Number two, you're kind of detailed oriented. Like you like to dot the I's, or I'm sorry, yeah, dot the I's, cross the T's, make sure everything looks really good before you move on. You might even be kind of organized. Is anybody like that in here? Yeah, some of us are. That's a very typical trait. Now, some people, it might be organized chaos. That's okay. It might not look organized on the outside, but you know where everything is and you got, you know, all the details. But that's kind of what this is. It's kind of like re-looking at this and making it, I don't want to say perfect. I don't want to, perfectionism can get you in trouble too. You take too long before you actually release something. Some of us might be guilty of that too, and that's okay. But we want to put our best foot forward. All right. And we want to make it readable. And you always want to think not how I think it looks, but how somebody who's going to make this part, do they have enough information to make it? And is it clear? Okay. All right. And then visualization. Now this is going to kind of, and this is not here to make you seem like, oh, I don't know how to visualize. I don't know how to do that yet. But let's say we have a part like this and we just have our three views, front, top, right side view. Okay. As we get better and better at this visualization thing, okay, and when we look at a part like this, you start kind of trying to figure out like, what's the high parts? What's the low parts from the front to the top? Okay. Now, if we go towards the end of the chapter, there is an answer key for this. We go to page, right at the end, thought. Sorry. I know what I'm looking for. Oh, here it is. On page 258, at the bottom of page 258. Okay, those are the three official multi-view front, top, right side views. Okay, so like a part like this, does anybody like feel like, yeah, I know what it's going to look like? Or do you feel like, ooh, I got to kind of think about this? in this case, you know, some of the parts that we've seen earlier are quite simple, but in this case, as we look, oh no, did it disconnect really? Oh, here it is. Okay. All right. As we look down here is the actual part. Okay. Do you see how a part like this, adding this as an additional view, an isometric up in the right-hand corner would be very advantageous? Okay. So as you know, those are decisions as a designer you get to make. They might take a little bit longer to put in there. They might take up a little bit more space, but when we've got complex parts that have a lot of different surfaces and a lot of stuff going on, this all of a sudden like clears everything up. Okay. So so again, making sure that we're putting enough information on that that is going to reflect exactly what we're looking for, because we don't want to assume anybody is going to know exactly what we need. And then also views of surfaces. Now this really comes into effect where we just go back to what do we see? What edges do we see exactly as we project that view onto our projection plane / piece of paper. Okay. So I think we've encountered a little bit of this as we've looked at things. Angles as well. We still continue to, what does that front view look like when I look straight on? Top view. And sometimes if those angles are kind of going back or forth, they are going to be foreshortened and such. But we have a way of adding views called auxiliary views that we can then get the true size and shape of something. So that would be to come when we have especially included angles like that. Similar shapes on surfaces. Interpreting views. And this is really that visualization piece. But like I said, there's nothing that we can really do more than get experience. I feel like that's the best way to do it. So here are some ways that you can think of that. And then just kind of looking at, there's not just 2D CAD systems out there like AutoCAD. There are 3D systems that create the models. And those models, those isometric views, again, don't forget about those when we're creating our drawings, because they can really help to, envision actually what we're trying to get across. All right. So I am going to move this down just a little bit. And that takes care of the module 6. So I think what I'm going to do is I'm actually going to stop this video now. And then I'm going to start a new video, a new recording for our orthographic projection practice worksheet that I have for us. So I'm going to stop here, but there will be another video for you to watch.